Question number 23. In a reaction A plus B2 gives AB2, we need to identify the limiting reagent in the following. First of all, a limiting reagent is the one which completely consumed in a chemical reaction. So here the chemical reaction is A plus B2 gives rise to AB2. Now we've been given various conditions, then we need to figure out which one is the limiting reagent. So let's start with the reaction itself. A plus B2 gives rise to AB2. And here, since we are only talking about the reactants, I am only concerned about the reactants. So 1 mole of A reacts with 1 mole of B2. Similarly, 1 atom of A reacts with 1 molecule of B2. Okay, so this is what is given to us. Now, we need to figure out which are the limiting reagents. First question, 300 atoms of A. So here, 300 atoms of A reacts with 200 molecules of B. So here you have 300 atoms in our chemical reaction reacting with 200 molecules of B. Now from this above statement or whatever I've written, we know that one atom reacts with one molecule. So if 200 molecules are present, then only 200 atoms will also undergo a chemical reaction. So B2 is completely undergoing a chemical reaction. Because of that, B2 is the limiting reagent, because here 200 molecules completely will get consumed and you'll still have 100 atoms of A still remaining. Next one, 2 moles of A is reacting with 3 moles of B. This is again similar to the previous one. Here, no, I'm sorry, it's not similar to the previous one, I'm so sorry. 1 mole of A reacts with 1 mole of B, which means 2 moles of A will react with 2 moles of B, which means 1 mole of B is still remaining, making A the limiting reagent, because A is completely getting used up in the chemical reaction. So here the limiting reagent is A. Let's go to the next one. If you notice, this particular equation, both of them are in a 1:1 ratio. And if it is not following the 1:1 ratio, whichever is in the less amount is becoming the limiting reagent. So 100 atoms of A reacting with 100 molecules of B2, which means you do not have a limiting reagent. It's a stoichiometric, properly stoichiometric condition. So all of it is getting used up. 1V, that's the fourth one. You have 5 moles and of A is reacting with 2.5 moles. So here it is not a 1:1 ratio. Here you have it as this is basically 1:2 ratio, right? So 2.5 is 1 and this is 2. So 2:1 ratio rather. So whichever is in excess is going to remain extra. So whichever is less, that becomes our limiting reagent. So 2.5 moles, that is the limiting reagent. So B2 is the limiting reagent. Similarly, 2.5 moles of A reacts with 5 moles of B2, which means this thing has just gotten flipped. So our 2.5 moles is the limiting reagent. So A is the limiting reagent. So whichever substance gets used up completely in a chemical reaction, that is the limiting reagent. And since in this particular reaction, based on its stoichiometric equation, because it is in a 1:1 ratio, the simple trick that you can remember is that whichever substance is in less quantity, that automatically becomes the limiting reagent. Question number 24. Dinitrogen and dihydrogen react with each other to produce ammonia. According to the equation, N2 plus 3H2 gives rise to 2NH3. We need to calculate the mass of ammonia produced when 2.00 into 10 to the power 3 grams of nitrogen reacts, or dinitrogen reacts with 1.00 into 10 to the power 3 grams of dihydrogen. And is there any amount of reactant which will remain unreacted? And if yes, which one of these is going to remain unreacted? And what will its mass be? So first of all, this equation is a balanced chemical equation because the mass of the reactants equals to the mass of products, or this particular reaction follows the law of conservation of mass. So N2 plus 3H2 gives rise to 2NH3. This is also a gas. So first we need to calculate the number of moles of nitrogen, dinitrogen and dihydrogen. The number of moles is calculated by the formula mass by molar mass. So mass over here is 2.00 into 10 to the power 3 grams. Molar mass is 28 because 2 and 2, right? So grams per mole. So here the number of moles of nitrogen is 71.43 mole. Similarly, moles of hydrogen is calculated the same way. So here you have 1.00 into 10 to the power 3 grams divided by 2 grams per mole. So this is simplified to give us 500 mole. Okay, so according to the above equation, 1 mole, let me write it. So 1 mole reacts with 3 moles of hydrogen to form 2 moles of ammonia. So 1 mole of dinitrogen reacts with 3 moles of dihydrogen to form 2 moles of ammonia. So 1 mole of nitrogen requires 3 moles of hydrogen. So 71.43 moles of nitrogen will require how much of hydrogen? This is given by 3 into 71.43 moles. And when this is calculated, we get 214.429 moles. So this means the 71.43 moles of nitrogen requires how much hydrogen is what we consider. We just had to multiply this with 3 because 1 mole requires 3 moles of hydrogen. But this 214.29 is the required number of moles. But the number of moles which are present are 500. This makes nitrogen the limiting reagent. So nitrogen is the N2 is the limiting reagent, which means our hydrogen will remain unreacted. Okay, so that is the answer for the second one. But first, let's calculate the mass of ammonia which is formed. So 1 mole of nitrogen reacts with 3 moles to form 2 moles of ammonia. So 71.43 moles of nitrogen will form how much of ammonia? How many moles of ammonia? So we'll take 71.43 moles of N2. So it reacts with H2 to form NH3, and this is given by 2 divided by 1 into 71.43. We are just multiplying it with 2. So, and this gives us an answer of 142.86 moles. So we have calculated the number of moles. Now based on this formula, number of moles equals to mass by molar mass. If we want to calculate the mass, we just have to multiply the number of moles, that is 142.86 moles, into the molar mass. Molar mass of ammonia is 17 grams per mole. This and this gets cancelled, leaving behind grams, and this is equal to 2428.6 grams. So first we basically took the we calculated the number of moles, because we know the number of moles of nitrogen which is reacting, and from the number of moles we calculated the mass, because the number of moles equals to the mass divided by the molar mass. Next, the second question is, will any of the two reactants remain unreacted? As we know, we saw here, hydrogen is going to be unreacted and nitrogen is the limiting reagent. So how much of hydrogen is left? So 214.29 is the moles of hydrogen which is reacting. So moles of H2 reacted will be equal to 214.29 moles, and moles of hydrogen which is present is equal to 500 mole. So moles of hydrogen unreacted would be equal to 500 minus 214.29 moles, that is equal to 285.71 moles. So first we have calculated the we've calculated the number of moles of hydrogen which is unreacted. So I'll just erase this over here. I'll just write this over here, 214.29 moles. So we have calculated the number of moles which is unreacted. So mass of hydrogen which will be unreacted would be equal to 285.71 mole into 2 grams per mole. This is again here the same thing which we did here. So mole will get cancelled, leaving behind mass. So 571.42 grams. Now first of all, here in this question we were supposed to calculate the mass of ammonia produced. But before you can calculate the mass of ammonia produced, you need to figure out which is the limiting reagent, because had we substituted 500 moles of hydrogen reacting and that leading to the formation, it would have gotten complicated, because not all of hydrogen is undergoing the chemical reaction. Also, it is easier over here because 1 mole gives rise to 2 moles. It's easier to use this because 1:2 is the ratio. Here it is 3:2, which means there'll be a little more math getting involved, right? So first we calculated the number of moles of nitrogen and hydrogen which is involved in the chemical reaction according to the masses which are given. So number of moles is calculated by the formula mass by molar mass. So based on this stoichiometry, 71.43 moles of dinitrogen will require how much of hydrogen? Because here we know it is in a 1:3 ratio, we just multiplied it, which meant it only required 214.29 moles of hydrogen. However, in our chemical reaction, we have 500 moles of hydrogen which is present, which makes nitrogen our limiting reagent. So because of that, we took the nitrogen, moles of nitrogen, and we took 71.43 moles of nitrogen reacts with hydrogen to form how much of ammonia, and this was directly done by multiplying the number of moles of nitrogen, because it's twice, right? It's twice the number. So that gave us the number of moles of ammonia being formed. Again, mass equals to So number of moles equals to mass by molar mass. So mass would be equal to the number of moles into the molar mass, and that gave us the mass of ammonia. By our previous calculations here, we figured out that one of the two reagents, that is reactants, that is hydrogen, is remained unreacted. So we got to know that the moles of hydrogen which is reacted is 214.29 moles. Moles of hydrogen which is present is 500. So we just subtracted these two values to give us the moles of unreacted hydrogen, and mass is again calculated similar to the one here. We just multiplied the molar mass and the number of moles which are present to give us the mass.